Hi students, this is AJ sir. Let's study 10th standard ICSE Math, Chapter 15E, Similarity, Advanced Applications. Exercise 15E, cancel questions 1 and 2. Let's start with question 4. Triangle ABC is similar to triangle PQR. Their corresponding medians are given and we have to prove them equal, these two ratios. Always draw diagrams for each sum in geometry. It's given that the two triangles are similar and we have to prove that AB upon PQ is equal to AD upon PM, where AD and PM are the medians, which means D is the midpoint of BC and M is the midpoint of QR. In order to prove this upon this is equal to this upon this, it seems that we'll have to prove this small triangle similar to this small triangle. This way, we will be able to prove what is required by CPST. But how do we prove these two triangles similar? We know that this angle will be equal to this angle because the big triangles are similar, so obviously the angles are equal. But I don't have anything else. Yeah, it's true that AB upon PQ is equal to BC upon QR by CPST for the big triangles being similar. But how will that help in proving the small triangles similar? Well, when I say BC upon QR, I know that instead of BC I can write twice of BD because D is the midpoint of BC. Similarly, instead of QR, I can write twice of QM because M is the midpoint of QR. By doing this, I can cut 2 and 2. So I am getting AB upon PQ is equal to BD upon QM. So AB upon PQ is equal to BD upon QM. So I got at least two pairs of sides in ratio and I got the angle between the two sides equal. That's enough for me to prove the two small triangles as similar by SAS test. And then I get what is asked by CPST, corresponding parts of similar triangles. Next, question 6. Again, triangles are similar, already given. And this time they are giving us angle bisectors. We have to prove the ratio is equal. So draw the diagram on your own. Let's see if you're getting it. These two big triangles are similar and we have to prove that AB upon PQ is equal to AD upon PM. Quite similar to the previous sum. Clearly, we'll have to prove the two small triangles similar. Let's see what we have. I've got angle B equal to angle Q. Clearly, because the big triangles are similar, so by CPST the angles are equal. Now, the entire angle A is equal to the entire angle P by CPST. Since AD and PM are the angle bisectors, I can use that property to state that twice of angle BAD is equal to twice of angle QPM because BAC is twice of BAD. This is an angle bisector. So the two angles are equal. Similarly, instead of writing QPR, I can say twice of QPM. So if I cut 2 and 2, I'm proving the two angles equal. So this angle equals this angle. So I got these two angles equal to these two angles respectively. So the two triangles are similar by AA test, and then by CPST we get what is asked. Make sure you write all the reasons the way I have. Next, the 8th question. The diagram is already given and we have to prove that AB upon BC is equal to PQ upon QR. It's given that the three lines are parallel to each other. This is basically the theorem of equal intercepts on parallel lines, but we will be using similarity to prove this. More specifically, we'll be using BPT. We will join AR first of all so that we get two triangles under consideration. Triangle ACR and triangle RAP. In triangle ACR, BD is parallel to CD. So by BPT, we can say that AB upon BC is equal to AD upon DR. Similarly, in triangle RAP, DQ is parallel to AP. So I can say that RD upon DA is equal to RQ upon QP. If I reciprocate it, that is invertendo, it means that AD upon DR is equal to PQ upon QR, but AD upon DR was AB upon BC, so AB upon BC is equal to PQ upon QR. From equation 1 and 2, we prove it. Cancel questions 10 and 11 and let's do question 12. Triangle is given. P, Q, R are the midpoints. We have to prove that the smaller triangle is similar to the bigger triangle. Well, in triangle ABC, if P and R are the respective midpoints, then by midpoint theorem, PR is half of BC. That's the midpoint theorem. Actually, PR is also parallel to BC, but that is not required for our sum. So I just proved that PR is half of BC. Similarly, we can say that RQ is half of AB and PQ is half of AC, all because of the midpoint theorem. So that means PR upon BC or PQ upon AC or RQ upon AB all are equal to 1 upon 2. So if the three sides of both the triangles are in ratio, the two triangles are similar by SSS test, which is what we wanted to prove. But make sure the naming of the triangles are corresponding. PRQ is similar to CBA. It goes in reverse order. Only then will you get these ratios names correct. So PR upon BC correct, RQ upon BA yes, and PQ upon CA yes, matching. So always check that. Next, the 14th sum. Mark it as IMP. The two similar triangles are equal in area. That is given. Prove that the triangles are congruent. Okay. Here, no diagram is given, no names are given. So the given is not given, so we'll have to write the given. We are giving the names A, B, C and P, Q, R. So we'll have to write the given compulsorily. Given that this triangle is similar to this triangle, so also it's given that the areas are equal, to prove that the triangles are congruent. So solution. Since the triangles are similar, the ratio of their areas will be equal to the square of the ratio of their corresponding sides. That is the theorem of areas of similar triangles. So it is equal to this, this as well as this. Now if these are equal, because the triangles are similar, and it's also given that areas are equal, so if I cut it, both are equal, so the answer is 1. That means each of these ratios is equal to 1. That means AB square upon PQ square is equal to 1, BC square upon QR square is equal to 1, and AC square upon PR square is equal to 1. Now when I say AB square upon PQ square is equal to 1, if I cross multiply, it simply means that AB square is equal to PQ squared. If I take the square root, it means AB is equal to PQ. Similarly, BC is equal to QR and AC is equal to PR. So I have just proved that the three sides correspondingly are equal. That means that triangles are congruent by SSS test. Now the 15th sum is also IMP. The ratio between the altitudes of two similar triangles is 3:5. we have to write the ratio between the corresponding medians, the perimeters and the areas. Quite a big sum. Again, no diagram, no namings, no labeling. So since the given is not given, we'll have to write the given. This is the diagram. What is given? That the two triangles are similar. Let the AL and PM be the respective perpendiculars or altitudes. Let D be the midpoint of BC and E be the midpoint of QR. That means AD and PE are the respective medians. Also, it is given that AL upon PM is 3 upon 5. All of this was given in the question. And what do we have to find? Ratio of the medians, ratio of the perimeters and ratio of the areas of the triangles, the big triangles. First, let's focus on getting the ratio of the medians, AD upon PE. That will come by CPST obviously. Now, it's given that this is 3 upon 5. It's a ratio, by the way. I can't say 3 centimeters and 5 centimeters, although I could have said 3x and 5x. So 3 upon 5. How do I derive a link between the altitude and the median? Directly, it's not possible. Which two triangles should we prove similar so that by CPST I can get the value of AD upon PE? Small triangles would be a bit difficult. Now my strategy will be, if AL upon PM is given, what if I can use it to get AB upon PQ ratio, and then from that I can get AD upon PE ratio. So step by step, first of all, how do I get AB upon PQ ratio? Well, that is possible if I can prove this small triangle similar to this small triangle, that is ABL similar to PQM. In those two triangles I've got one thing at least, right angle and right angle. Great. I need one more thing. Well, angle B is equal to angle Q, because the big triangles are similar, right? So the angles will be equal by CPST. And now focusing on the smaller triangles, angle equal to angle proved, this angle equal to this angle 90. So triangle ABL is similar to triangle PQM by AA test. That means AL upon PM is equal to AB upon PQ by CPST. So I have proved AB upon PQ also equal to 3 upon 5. Now I would like to prove triangle ABD similar to triangle PQE, because if I do that, then AB upon PQ will be equal to AD upon PE by CPST, and AB upon PQ we already found out as 3 upon 5. So now I will get the answer of AD upon PE as 3 upon 5. But how do I prove those two triangles similar? Yep, angle is equal, correct, but that's it. What else? Well, we have done such a median sum earlier, so the same logic will be applied here. See, AB upon PQ is equal to BC upon QR, because the big triangles are similar. But BC can be written as twice BD and QR can be written as twice QE. So 2 will get cancelled, and hence I will be able to prove that AB upon BQ is equal to QD upon QE. So I got two sides at least in ratio respectively, and the angle between them is also equal. So I will be able to prove triangle ABD similar to triangle PQE by SAS test. So now the sum is taking shape. So always try to solve it with the help of the diagram before solving it with pen. Try to understand the logic in the diagram itself. Then the flow of the sum would come automatically. So as I said, the triangles were similar, the big triangles. So I'm writing the CPST because I know that this will be useful in the future, and even the angles are equal. Keep looking at the diagram after every step. Now in triangle ABD and triangle PQM, we've got angle equal to angle and 90, so they were similar. They're similar by AA test. So this is equal to 3 upon 5 by CPST. So I've proved AB upon PQ is equal to 3 upon 5. Now AB upon PQ is BC upon QR from equation 1, you know, the CPST of the big triangles. And BC, as I said, is twice of BD, and QR is twice of QE. 2 and 2 cut, so I get this. This will be used in proving triangle similar by SAS test, because the two sides are in ratio and one angle is equal, one pair of angles are equal. And if the triangles are similar, then by CPST this follows, don't forget to write it. And we prove AD upon PE, which, if you remember, they are medians. That is also equal to 3 upon 5. But make sure you write it in the ratio form in the end, because they've asked us the question in the ratio form. So don't forget this step. Next, we want to find the perimeter ratio. So I think it should strike you that we will use the theorem on equal ratios here, because first of all, these sides are all equal to 3 upon 5 from equation 1, that is for the big triangle CPST, from equation 1 and 2. And the theorem on equal ratio says that if you just add all the numerators upon the addition of the denominators, the ratio still remains the same. And this is nothing but the perimeter of the triangle ABC, and the denominator is the perimeter of triangle PQR. So we get the ratio of the perimeter also as 3:5. And finally, the ratio of the areas of similar triangles, the big triangles, is equal to the square of the ratio of their corresponding sides, which we knew it is 3 upon 5. So the square of that is 9 upon 25. So the final answer is 9:25. Next, cancel the 17th, 18th, 19th sum. Even cancel the 21st sum, and let's do the 22nd sum. Mark it as IMP. So 14, 15, 22 are all IMP sums. In the 22nd sum, there are two isosceles triangles, and they have equal vertical angles as well. That means all three angles seem to be equal then. Show that the triangles are similar. And the second part, if the ratio between their areas is given, find the ratio between their altitudes. Since the given is not given, you have to write the given. We are assuming two triangles to be named as ABC and DEF. Let's say AL is the altitude out here and DM is the altitude out here. They're isosceles, that means AB is equal to AC and DE is equal to DF. And the vertical angles, entire angle A is equal to entire angle D. So all of this needs to be mentioned in the given. Also, the ratio of the areas of the triangles is given. To prove that the triangles are similar, and then we will find the ratio of AL to DM. First, how do I prove the big triangles similar? Yep, one thing we've got, angle BAC is equal to angle EDF. But that's it. What else? This 90 won't help. No, we want something in the big triangle. Yeah, this B angle is equal to C angle, base angles, and E is equal to F. But how can I prove that angle B is equal to angle E? Well, that will be a longer process. I can use the X method and all, but I'm using a different strategy. I know that AB is equal to AC, isosceles triangle property, or rather it's given in the given here. And I also know that DE is equal to DF in the other triangle. So I can just take a ratio of these two equations. So this upon this will be equal to this upon this. And if I got two sides correspondingly equal, and I've got one angle between them as equal, That's good enough for me to prove the two triangles similar by SAS test. So the first part is done. Next, since the ratio of the areas of the triangles are given and we know that they are similar triangles, so but the theorem says that that should be equal to the square of the ratio of their corresponding sides, which I am taking as AB upon DE, the whole squared. And the ratio is given as 16 upon 25. The square becomes square root and I get the answer of the corresponding sides as 4 upon 5. But that's AB upon DE, 4 upon 5. This is 4 upon 5. But they want AL upon DM. Well, we've done such a sum before. Now we will try to prove the smaller triangles as similar. But how? Well, we've got angle equal to angle already, CPST, and we've got 90 equal to 90. So by AA test they are similar. That means AB upon DE is equal to AL upon DM. That means AL upon DM will also come out to be 4:5. These are the steps which I just spoke. Next, cancel the 23rd sum. Let's do the 24th sum. This triangle's diagram is given. Finally, the given is given, so we don't have to write the given. And we have to prove 4 things. First, prove them similar. That's very straightforward. Visualize it. ADC, the upper triangle. BEC. Oh, that's so easy. Angle is equal, 90 and 90. So if you want, you can draw the two triangles separately as well, if you can't visualize it well. And then they are similar by AA test. Don't forget the reasons and the statements. You lose half mark every time. Roman number 2, just write the CPST. I don't know which of the ratios will be useful. I'm just going to write everything and then look at the question again. They want CA into CE and CB and CD. So where is CA? Here it is. Where is CE? Here. Where is CB? It's here. And where is CD? Here. So this was not required. So just cross multiply this and we get this. Now Roman number 3. We have to prove the big triangle ABC similar to the triangle DEC, the smaller one. We've got a common angle C, but I need more. What else? If only I can prove a pair of corresponding sides in ratio, then by SAS test I can prove them similar. So we are going to use this. Let's continue this. CD goes down here and CE goes down here. So I'm getting CA upon CD equal to CB upon CE. Why? Look here. CA upon CD. See, this belongs to the big triangle. This belongs to the small triangle. Is equal to CB upon CE. CB, big triangle, upon CE, small triangle. So now in triangle this and this, we have a common angle and we already proved the pair of sides in ratio. So by SAS test, the two triangles are similar. Write the naming properly because then the CPST ratios will be correct. And if you cross multiply, let's say these, no, not these, yeah, these and these, cross multiply, we get what is asked. Next, 25th sum is cancelled. Cancel 26, 27, and let's do the last sum, 29th. 30th is for homework. Here again the diagram is given. It's also mentioned that AB is parallel to DE and BC is parallel to EF, and we have to prove two things. First of all, prove AD upon DG is equal to CF upon FG. So pause this video and think, what technique will you use to prove this equal? Did you think about BPT? You're right. So I'm gonna mention which lines are parallel. So in triangle GAB, if this is parallel to this, that means this upon this is equal to this upon this by BPT. And then in this triangle, EF is parallel to BC, so that means this upon this is equal to this upon this. So combining the two equations, I'm getting GD upon DA is equal to GF upon FC. And just do a reciprocal of that invertendo, you will get AD upon DG is equal to CF upon FG, which is what is asked in Roman number 1. So these are the steps of Roman number 1. Pretty easy, huh? But Roman number 2, we have to prove triangle DFG. Look in the diagram, similar to triangle ACG. So before solving any sum, first thing you should do is always draw the diagram. So this small triangle and the big triangle, we've got a common angle. Great, but I need more than that. One more thing or two more things. What do we have here? Well, we know that this upon this is equal to this upon this. So using componendo, we can prove that GD upon GA is equal to GF upon GC. Then we can have a pair of corresponding sides in ratio and an angle in between is equal. So by SAS test, we can prove them congruent. So that's what we are going to do. After proving this, fortunately, we have already done an invertendo. So we just have to do a componendo, that is numerator plus denominator upon denominator, and we get GA upon GD is equal to GC upon GF, which I just showed in the diagram. And because the common angle is also there, the two triangles are similar by SAS test. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.